Hello, I am Ishan, fourth year undergraduate student of Computer Science Department, and this is my presentation to Assignment 2 Temporal Database of the Advanced Database course. Let's move on and let's start with what is a temporal database. So basically, a temporal database is nothing but a values which are also associated with some time periods during which they can be valid as one of its definition. So as the example given below, there are few items and their values, and the temporal database does nothing but assigns a sense of timing of start or end to the values present in the rows. So as you can see here, the value is A, which corresponds to 100, and it is given a start and end value of X and Y. So there are various kind of approaches that have been taken to incorporate this into the system of database. One was to create a different kind of variable which stores the start and end, but it was somewhat harder to implement. So this using the already existing variable systems of time and date, this system was created where a column or specifically two columns, one for start and end, was created, where there are various instructions like create and alter. So let's move on. So this is a few more concepts regarding the temporal database, which is valid time, transaction time. Valid time is for the time period during which the row is correctly reflected for the particular value, and the transaction time is the time in which the time frame for the valid time was input. For example, if I want to input a time frame of tomorrow to day after tomorrow for a particular row, so that is the valid time for which something is valid. But the transaction time is the time when which at the time in which I have entered the record, which is today or now. Few more examples of a temporal database would be for insurance and finance, banking, where there is a sense of time, and the values of rows corresponding is changing from instance to instance, and it is required for some other purpose when we want to check if what is the record for a past time and what was something that was visible to a single particular person at some time which was a long time ago, right? Something like that. So moving on. So the example which I am going to explain is a hospital management system. So it is very important for hospitals to maintain logs at what time which doctor has visited which patient and has given which prescription. So for example, a team of doctors are treating a patient. For example, there are 5 doctors treating a patient. So they need to maintain logs of at what time a doctor has started visiting and ended his or her visit, and what the particular doctor has prescribed. So this helps them to keep a record or track what medication has been given to each person. So because to determine in the future what medicine was given, what course of action was taken, it is very important to maintain this kind of a data structure. And it might change, right? The prescription might change from time to time. The doctor visiting that person may change, and there might be updates that have to be given if some wrong entry has been put, right? So this is a important application of temporal database. Moving on. So this is the first kind of temporal database, which is an application time period table. In this, the valid time is input, where the start and end time are manually or specified by the user, and it is the table is created as such, like create table, hospital records, patient ID, doctor ID, e start, e end, prescription, and period for visit period, e start, e end. So this is the template that has to be used to create the temporal database, where the start and end time is specified for the uh, particular patient ID, doctor ID, etc. So these are some of the example queries where I have inserted two of the values for the corresponding patients, hospital doctors, and their valid time, right, manually. So this was the output that I received. So as you can see, there are the two uh, two records have been inserted, and I have output the corresponding record. And as you can see, there are patient ID, doctor ID, start, end, and the prescription. So prescription is a text which can also be null if you don't want to fill it. So after both of the records have been filled, this is the final table where, as you can see, there is a patient ID, doctor ID, start, end. And important point to note is that the time or the date of this two timestamp is user defined and not not the time of the system. Moving on, these are the queries which can be used to update the records and to delete the records. Some important and interesting point of the update record is that if there is if the update of the new record is discrete of from the records present in the current table, a new record is just added. But if there is some update where there is an overlap between one or more of the records already present in the table, the records present in the table will be broken down, and the record present will be updated, and the two or more new records will be inserted. So in this thing, if we are inserting for patient 101, as you can see, the 101 had a start of 10 to 11, and we are inserting at 10:15 to 10:30. So the 101 is broken down into three, right? So one is from 10 to 10:15, another is from 10:15 to 10:30, and one more is from 10:30 to 11. So this is the corresponding update. And the delete is, I think, pretty intuitive to understand. It is deleted as per the timestamp 2 and from 2 where the patient ID is given. So the corresponding one is deleted. So here also the same thing as an update. If the delete correspond to a period between two records, so that part is deleted, and two new records are created using the trigger function where the other two parts of the records are inserted. So here from 1020 to 1025 is deleted. So two more records are created where 1015 to 1020 is inserted, and 1025 to 1030 is inserted. So this is the corresponding table. Moving on, we can also alter the table base record to add a primary key, so that some overlapping time periods are not allowed to be inserted. So as you can see, I have updated the alter table, and it is not allowing me to insert some time period which is having some constraint, or it is having some overlap with already existing time frames. And one more interesting part is, if we want to create some foreign table which corresponds to a key of the already present table, so that there is some fundamental ambiguities, like for example, a doctor has started practicing from so and so to so and so time, but there is some patient who has the doctor visiting uh, even before the doctor has started practicing, right? So that is some ambiguity, and using this table and adding a foreign key to the already present existing table, we can save such mistakes. Moving on, this is the next part, or the system version table. Here, instead of inserting some manual values, the only main difference is that the timestamp is taken from the system, or the system versioning. Here, the input is taken just for the patient ID, doctor ID, and the prescription, and the timestamp is directly taken from the existing time from the machine, right? So this is the time of the machine, the start time, and the end time is taken out to be some some very big value. If and when if we update it, it changes, which I'll be explaining in a little while. So here, as you can see, we create the table, and we take these two columns as visit start and end. with system versioning. So these two of the start and end are taken from the machine, and we won't or we can't take it manually by the user. So in the practical world, if the doctors can't input it manually, they can have some fingerprint or some system, and using that the machine will directly take the time and it will insert it without the doctor being having to mention the time and the exit time that the doctor is exiting or entering the room of the patient. So this is a upgrade of from the previous system, right? So we can insert, and these are the two tables. As you can see, I have inserted. And moving on, I have updated the record. So instead of having a null for the prescription for this one, for the patient 1, 2, 3, I have added a dolo in the prescription. And if we select star, you can see all the both the patient IDs are shown. Next, so this is also one interesting part. As you can see, if what we can do is we can not just see the current value, but we can also see the past value. So before this update was made, at what time we can check for a time before this update was made from the system time as of 9/6. So this update was made at 7/9. So we are checking for checking the record at a time of 9/6, right? So what we can see is that as of this time, the uh, value for the prescription was null and null. So the output of the table will be null and null instead of having dolo and null, which is the current value at the current time of the machine which is running, right? And also, if we delete, we can see that the values is getting deleted. So as for the update also, if we check the value after deleting the values, if we check for select star at some other time before the delete was made, obviously both the records will be shown and not just the current value of the table. So as you can see here, we are checking for a time before the delete. So the two, both the rows are being visible. Moving on, this is we saw the records for as of. Here also as of was used. So instead of that, what we can do is also we can use from and to, where the time can be manually set for a range of time or date. So we can do select star from this to this, and as you can see, we can get all the records from the time this both were valid. So if we select star from this to this, we'll get this too. If from some other time before the prescription dolo was updated, we can see that it's null and null. So one interesting observation from this is that if we take a time before some update was made and after some update was made, so we'll get all the records before and after the records, even for the same record. So as you can see, the update was made at 7/9. So if I check for a prescription or the table from a time before and after the update was made, if I select a time as such, I'll get the corresponding record for patient 123, both before the update, which is null, and after the update was made, which is dolo. So both the records will be shown because the system had rows corresponding to that particular patient ID before and after, that is that has been changed. So both the records will be output. Next, this is the last and final part, which is the bitemporal tables. So in the physical world, what this will correspond to is, for example, if a doctor wants to make some future rounds, or that he or she is telling that I had been present during this time, or I will be present during this time. So the doctor can enter a time period for visit for a future time or for a past time if someone for due to some reason he or she has forgotten it. So the time the doctor is entering the record is the transaction time, and the time during which he or she will be present, that is being noted down in the database, is the valid time, right? So this is the format for creating the hospital, where the patient ID is there, doctor ID is there, visit and end time. This is the valid time which can be manually input, and the System start and system end is the time which is being entered automatically by the machine. So these are the constraints of our primary key, and this is an example of inserting into this where only the manual date is for the visit start and visit end, which is the valid time, is input, and the other time, which is the system start and end, is manually is automatically input by the machine. So if I insert these two tables and output the uh, table, I'll see both this, and as you can see, there is a visit start and end which was input manually, and one is the system start and end which was input automatically. Thank you.